Okay, let's do another example now. Graph a sine function where the period is equal to 6 pi. So once again, if my period is equal to 6 pi, I can find the interval between my critical points by doing 6 pi divided by 4. I can simplify top and bottom by 2, and I get that the interval between my critical points is 3 pi over 2. So let's find that in the graph. Once again, remember that my sine function always starts at 0, 0. And my first critical point is going to be at 3 pi over 2. So from 0 to 3 pi over 2, this is where I'm going to end at. And to the right, I can't fit another critical point, but I can fit another critical point to the left. So once again, I'm going from 0 to negative 3 pi over 2 now. That's going to be where my other critical point is going to be at. Graphing, you have to remember that sine starts at 0, 0, and the first critical point you find is a point of maximum. So let's graph that. Is a point of maximum. And to the left of the y-axis, you should know that you are going to have a point of minimum. Your first critical point is a point of minimum. So let's graph that over here. And you can't fit any other critical points in your graph, so your sine graph is going to look something like that. Please, please do not make this a straight line. Do not, okay? This is part of the sine graph. You should have this little curve over here and this little curve over here, showing me that you know that a sine graph is a curved graph. Okay, one more example. Graph a sine function where the period is equal to pi over 2. So let's start graphing. If our period is pi over 2, we have to get pi over 2 and we have to divide it by 4. So you're going to have pi over 2 divided by 4. And if you don't remember how to do this, we can write 4 as 4 over 1. How do we do a division of fractions? You multiply the first term by the reciprocal of the second term. So you're going to have pi over 2 times 1 over 4. Now it's a multiplication of fractions, top, top, bottom, bottom. Pi times 1 is pi, 2 times 4 is 8. So the intervals between our critical points will be equal to pi over 8. So once again, turning back to my graph, sine starts at 0, 0. And then we have to find intervals of pi over 8. How do we do that? Well, if you look at your axis, this is 0, this is pi, right? Half of this distance is pi over 2. Another half of this distance would be pi over 4, which means that pi over 8, let me do little tick marks over here. This would be pi over 4. And pi over 8, I have to divide pi into 8 little pieces. So each one of these little pieces is pi over 8. So let's start graphing. This means that I'm going to have a critical point over here, another one over here, another one over here. You can see that my graph's going to look terrible, but I'm going to try to graph it anyways. So I started at 0, 0. And then I have a point of maximum at pi over 8. Then I go down, back to the x-intercept, then I have a point of minimum. Then I go back, and I'm going to keep on doing that forever, but I'm not going to do this over here because it's going to turn into a mess. But my graph's going to look something like that, and it's going to go on forever like that, right? To scale, obviously, which I didn't do right now. Okay, last example. Graph a cosine function where the period is equal to 2 pi over 3. Notice that this exercise is asking you to find the cosine, the graph of the cosine function. So we're going to start not at 0, 0. We're going to start up at 1. So once again, if my period is 2 pi over 3, I have to get my period and divide by 4 to find the interval between my critical points. So I'm going to get 2 pi over 3 times 1 over 4. And this is going to be 2 pi times 1 is simply 2 pi. 3 times 4 is 12. I can simplify that, and I get pi over 6. So now I'm going to look at my graph. And once again, I have a cosine function, so I'm not starting at 0, 0. I'm going to start up here at 1. And then I have to find the intervals of pi over 6. Pi over 6 means that I'm going to get pi, and I'm going to divide this distance pi into 6 equal parts. So first, I'm going to divide it into 3 parts. I think this is kind of okay. So 1 part, 2nd part, 3rd part. Then each of these parts I'm going to divide once again to get pi over 6. And I should have divided this distance from 0 to pi into 6 equal distances. And this means that I'm going to have a critical point at each one of these x values. So starting with cosine, cosine starts at 1 and we don't go up because this is a point of maximum. We go down to find an x-intercept. So my first critical point will be an x-intercept over here. Then my second critical point over here is going to be a point of minimum. So let's graph that point of minimum over here. Then x-intercept again, then point of maximum, then x-intercept, point of minimum. And we could do this for the whole graph. If I had actual graph paper, it would have been looking better, but it's going to look something like that. We can do the same thing to the left, right? So I have this distance over here from 0 to negative pi. This is pi. I'm looking for intervals of pi over 6. So I'm going to get this distance, that is pi, I'm going to divide it into 6 equal parts. So let's do that. First, I divide it into 3 equal parts. Once again, this doesn't look very good. I think this looks a little bit better. So from here to here is 1, 2, 3 equal parts. And each of these parts I'm dividing in 2. And now I should have divided this distance pi into 6 equal parts. And once again, now I'm going to start graphing the critical points. So right now I'm up over here at a point of maximum. My next critical point will be a point of, will be an x-intercept. Then the next one, a point of minimum, then x-intercept, point of maximum, x-intercept, and we could go on and on and on. Your exit slope for today will be a problem very similar to the one that we already did. You have to sketch a graph of a cosine, be careful people, it's cosine, not sine, of a cosine function where the period is 4 pi over 3. Once again, your graph should be done in a similar way like I did the other 4 examples. Okay, your graph should contain all the critical points in between negative 2 pi and 2 pi. So I already made a sketch over here of how your graph should look like. I already labeled the axis for you. I already gave you the scale of the x-axis, okay? So all you have to do is get the period divided by 4 to find where you're going to graph your critical points. Graph the first critical point correctly for cosine, which is not at 0, 0, okay? And graph every single critical point that exists between negative 2 pi and 2 pi. Okay, I have a suggestion. You don't have to do this if you don't want to. You can do it by hand, just like I've been doing right here in this presentation. But if you don't feel comfortable doing it on a blank piece of paper, you may print one of the worksheets from the packet that I sent you, and then use one of the graphs to help you accurately graph. So you can cut out a little graph and then use that paper that's already graphed and labeled for you to accurately sketch your graph.